friends, welcome back to our YouTube channel Maths and Electronics Tutorials. In this video, we are going to discuss the remaining sums of exercise 2A. For more understanding of today's questions, please refer my previous videos. I have provided the link in the description box. Now, we will start the third sum. 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to n terms is equal to n of n plus 1 of n plus 2 of n plus 3 by 4. Solution. In this, we have to solve by using the fourth formula. So, in the first, we will take 1 into 2 into 3 and so on. So, A is equal to 1 and D is equal to 1. So, an is equal to 1 plus n minus 1 of 1 is equal to 1 plus n minus 1 is equal to n. In the second, 2 into 3 into 4 and so on. Then a is equal to 2 and d is equal to 1. So, an is equal to 2 plus n minus 1 of 1 is equal to 2 plus n minus 1 is equal to n plus 1. In the third, we will take 3 into 4 into 5 and so on. So, a is equal to 3 and d is equal to 1. So, an is equal to 3 plus n minus 1 of 1. So, 3 plus n minus 1 is equal to n plus 2. Therefore, the n term is equal to n of n plus 1 of n plus 2. Let S of n is equal to 1 into 2 into 3 plus 2 into 3 into 4 plus so on up to n of n plus 1 of n plus 2 is equal to n of n plus 1 n plus 2 of n plus 3 by 4. Next, put n is equal to 1 in S of n. We have to solve LHS is equal to RHS. In LHS, we will take n of n plus 1 of n plus 2. Then substitute n is equal to 1. So, 1 plus 1 of 1 plus 2. So, 2 into 3 is equal to 6. In RHS, n of n plus 1 of n plus 2 of n plus 3 by 4. So, 1 of 1 plus 1, 1 plus 2, 1 plus 3 by 4. So, 2 into 4 into 3 by 4. So, 4 get cancelled. So, 2 into 3 is equal to 6. Therefore, LHS is equal to RHS. Therefore, S of 1 is true. Next, put n is equal to k in S of n. We get S of k is equal to 1 into 2 into 3 plus 2 into 3 into 4 plus so on up to k of k plus 1, k plus 2 is equal to k of k plus 1, k plus 2, k plus 3 by 4. Assume S of k is true. Next, put n is equal to k plus 1 in the n term of LHS part of S of n. We get n of n plus 1 of n plus 2. Well, if we substitute k plus 1, we will get k plus 1 of k plus 1 plus 1 and k plus 1 plus 2. K plus 1 of k plus 2 of k plus 3. Now add the above value to S of k on both sides. We get S of k plus 1 is equal to 1 into 2 into 3 plus 2 into 3 into 4 plus so on up to k of k plus 1 of k plus 2 plus k plus 1 of k plus 2 of k plus 3 is equal to k of k plus 1 of k plus 2 of k plus 3 by 4 plus k plus 1 of k plus 2 of k plus 3. Next, k of k plus 1 of k plus 2 of k plus 3 plus 4 of k plus 1 of k plus 2 of k plus 3 by 4. Next, now we will take k plus 1 of k plus 2 and k plus 3 common. So, the remaining term is k plus 4 by 4. Therefore, S of k plus 1 is true. By the principle of finite mathematical induction, S of n is true for all small n belongs to capital N.